Guys, today I'm going to show you the three main types of volcanoes. So if you remember from our last lesson, we had cinder cone, the cinder cone volcano is pretty easy to understand. Okay, primarily because it has one vent. Okay. So you got your magma chamber. And you got your one vent traveling up towards the crater. Now, when the cinder cone volcano erupts, okay, it's gonna shoot out what you call explosive pyroclastic material. And this is just all types of gas and rock fragments and magma that's been ripped apart, and what we call is tephra. Okay, so the actual slope of the cinder cone volcano is pretty steep because when this tephra falls during a volcanic eruption, the heavy tephra falls near the crater and builds it. Okay, and then the lighter tephra, of course, falls over here because it can get shot farther, and the volcano is built that way. Okay, so remember, the cinder cone has one vent and it's explosive. Okay, it's an explosive eruption. Okay, next you have a composite volcano. So a composite volcano is similar, but it's much bigger. Okay, similarly steep because the volcano itself is formed in from similar material. But the main difference, which adds to its size, the composite volcano has many vents. Okay, it's got its real big vent, the Big Mama in the middle, but it's got all these other vents that contribute to the growth of the volcano when there's a violent eruption. Okay, so when this guy explodes too. It's an explosive eruption. Same thing, it's gonna shoot, but it's also gonna let out lava from the other vents on the volcano. Okay, so its growth is gonna increase much faster than a cinder cone. Okay. Composite volcanoes are spelled like this. Composite. Okay. So same concept, you got your magma chamber. And when this guy explodes, he's gonna build the circumference of the actual volcano much more rapidly than the cinder cone because there's so many exterior vents coming from the main vent. So when it explodes, it's going to shoot all that pyroclastic material and tephra, just like in the cinder cone, but it's just going to get built much more fast. Okay. Same concept. The explosion, the heavy tephra is going to land near the crater, or near the main crater. Okay, or the crater from which it came, or the vent from which it came, and it's going to cool, and it's going to add size to the actual volcano itself. Okay, so examples of a cinder cone would be Mount Vesuvius, and an example of a cinder cone would be Mount St. Helen is a very common example. So let's do Mount Vesuvius as a cinder cone. Okay, this had a really violent eruption that destroyed the city of Pompeii and about 2,000 years ago, in the year 79 AD. Composite volcano is in Washington State, Mount St. Helens. Okay. Huge volcano. So the last one we have is a shield volcano. Now, shield volcano is different. It's not explosive. So let me reiterate that these are explosive. Okay. Whereas a shield volcano pours out effusive lava. Okay, so the sides, the slopes of the actual volcano itself are not at a high angle. Okay, they're relatively close to the ground. The volcanoes are huge in diameter, but they're not tall. Okay, this is because the lava that comes out of the magma chamber it pours. It doesn't explode. It pours out of the side, out of the crater. Okay, so it doesn't explode. Pyroclastic material in tephra. It has very effusive and actually relatively thin lava. Okay, so since the two things, since the shield volcano doesn't explode, and because it doesn't have what we call viscous lava, so these two guys, the composite and the cinder cone, have very viscous, thick lava, whereas the shield volcano has very relatively thinner lava. So it moves a lot quicker, and then eventually, of course, it's going to cool and build the volcano and become new rock. Okay, but it's going to be much further away from the crater, or the place from which it came. These are shield volcanoes. Now, these tend to be huge in diameter, just not very tall. Good examples of shield volcanoes is every single volcano in Hawaii. The Hawaiian Islands are all made out of shield volcanoes. So remember, this guy's coming out, same thing. Same thing with the composite, you got several vents. Okay, and the vents really doesn't apply to this, because when the vents come, it just simply pours out of several different places. Okay, just creating a place where there's a lot of volcanic activity, not necessarily with violent eruptions that you would think of characteristically from a volcanic eruption. Okay, guys, these are the 3 volcanoes. Nice.